Hello students, welcome back to yet another session where we are going to start unit number 5 today, and we are going to see all the topics in unit 5 in subsequent sessions. So here we are going to see about air conditioning loads, outside and inside design conditions. And let me introduce unit number 5, and these are the topics: air conditioning loads, outside and inside design conditions, heat transfer through structure, solar radiation, electrical appliances, infiltration and ventilation. So this is a little I have taken this into single topic, and we are going to see all these contents in 4 or 3 sessions, because we have only 9 hours given for this unit, and I have divided into 9 topics. Uh, this topic alone will be a time consuming topic. That's why I have splitted this into various sessions. Next, internal heat load, apparatus selection, fresh air load, human comfort and IAQ principles. So this is another lengthy topic. This also we will discuss in 2 or 3 sessions. And effective temperature and chart, calculation of summer and winter air conditioning load, classification and layouts of plants. These are all simple topics. Air distribution systems and filters, and the last topic is air conditioning systems and controls, temperature, pressure, humidity, and its actuators and safety controls. So this is the last topic and interesting topic. We will be completing all these topics from 5th unit, and now we are starting air conditioning loads, outside and inside design conditions. So here air conditioning load estimation is the foundational step in designing an HVAC system. So heating, ventilation and air conditioning systems. So here it is the very foundation, very basic concept, and we need to estimate the load first, and then we have to design, or we have to establish the system. It determines the capacity required to maintain thermal comfort under worst case design conditions. So first we have to think about worst case design conditions. So from where we are going to develop a HVAC system, both externally climatic conditions and internally heat gain from sources inside a building. So these worst conditions we have to assume, and then we have to start designing a HVAC system. So classification of air conditioning loads. Air conditioning loads are generally classified into external, that is outdoor loads. So it is outdoor loads, and caused due to conditions outside the building structure. So whatever is happening outside the building, that is climatic changes. So that is nothing but the external loads. Includes solar radiation, ambient temperature, humidity, wind, infiltration, etc. etc. And the next one is internal load. So internal load is nothing but indoor conditions or indoor loads, and this is because arises from heat sources inside the conditioned space. So it is a confined space, and the things which are there inside the space, so that will also cause the load, that will also become a load to the air conditioning system. It includes occupants. So occupants are nothing but human beings who are sitting in that space, and lighting is also one of the cause, and appliances are different items inside the indoor space, equipment and ventilation, air. So apart from this, everything whatever article we have inside a room or space, so that will also cause the load. Outside door design conditions. So these are selected to ensure the HVAC system can handle peak weather loads for the region. So peak weather loads, suppose in Chennai, if it is coming 40 degree Celsius, we have to consider that 5 plus 5 degree. So we have to design a air conditioning system for 45 degrees. So that will be that plus 5 degrees will be the what you call tolerance. So if we design or if we consider worst scenario, so that may be 45 degrees, it will not go beyond 45 degrees. So we have to design for 45 degrees, and that will be suitable for every household in the Chennai. So these are selected to ensure HVAC system can handle peak weather loads for that particular region. And we have to consider this dry bulb temperature DBT. It indicates air temperature without moisture content, and peak DBT dry bulb temperature is used for sensible heat calculations, and the wet bulb temperature is indicates latent heat content due to moisture, used in coil selection enthalpy based calculations, and RH relative humidity, and it influences indoor humidity control. So this is related to indoor humidity control. And solar radiation. Solar radiation is actually the biggest cause, and adds to buildings heat through walls, roof, and fenestration. So fenestration is possible through glass windows, or even wooden windows also will facilitate this fenestration. So wind velocity, another factor is wind velocity. It affects infiltration rates, which contribute to unintentional cooling or heating load. Design day concept. So design day concept is nothing but selection of an extreme but realistic day, say 1% design condition from climatological data. So climatological data is nothing but the past climate data. So example, in Chennai, the outside design DBT could be 40 degrees Celsius. So with the wet bulb temperature of 28 degrees Celsius and relative humidity 60 percentage. And this is the one scenario, worst scenario we have to assume. And with this scenario, we have to design the HVAC system or air conditioning system. Inside door design conditions. So next content is inside door design conditions. So here these are target conditions to be maintained by HVAC system. So actually outside factors are not much affecting the HVAC system inside. So, but these are the conditions. These are more. These will have more impact than outside conditions, because even if we have well built structure, and that can minimize the outdoor conditions, whereas these are indoor conditions are very important to consider here. These are the target conditions to be maintained by HVAC system. So temperature generally 22 to 26 degrees Celsius dry bulb temperature. So this is the desired temperature, comfort temperature 22 to 26 degrees Celsius. It depends on application, and residences it can be 24 to 26 degrees Celsius. So that gives human comfort. And offices it can be 23 to 25 degrees Celsius. Hospitals it is little lesser, 22 to 24 degrees Celsius. So relative humidity indoor relative humidity, it should be typically maintained between 50 percentage to 60 percentage for comfort and health. And relative humidity is related to health, also human health, and it should be maintained within this range. And low relative humidity, it becomes dry air and discomfort, and relative humidity should be maintained. And if it becomes lower, then the air becomes dry, and it will cause the discomfort to humans. And higher relative humidity, the mold growth and pure IAQs. So here internal air condition, air quality, it will be very poor in this case, higher relative humidity. So inside door design conditions, air velocity is another factor. So comfort zone is 0.15 to 0.25 meters per second. Even fan should not cause more than this air. And high velocity, so there will be draft, and low velocity there will be stagnant, and that will cause the discomfort. And air quality, internal air quality, CO2 levels and VOCs, particulates must be within acceptable limits, and it should be maintained within acceptable limits. And fresh air ventilation is a part of load as per ASHRAE 62.1 standard. So illumination and noise, indirect, it will have indirect impact. Lighting adds to heat load. So combined effect, so total load estimation, so both indoor and outdoor, and the combined load is the sum of sensible and latent loads from both outside and inside sources, and the formula is Q total equal to Q sensible plus Q latent. So that is the energy internal, that is the heat energy, and where Q sensible includes wall gain, solar gain, occupants, lighting, etc. And Q latent includes infiltration, respiration, moisture, cooking, etc. So selection of design conditions, outdoor design selection based on Indian Weather Data Handbook IWEC, that is by ASHRAE and MNRE, and this is the whether based on the handbook, and this is the what actually temperature conditions are climatic conditions. And Chennai, it is dry bulb temperature 40 degrees Celsius, wet bulb temperature is 28 degrees Celsius, and RH is 60 percentage, whereas Delhi, because it is seashore, we have more humidity, relative humidity, and Delhi, it is 43 degrees Celsius and 25.5 degrees Celsius wet bulb temperature, and relative humidity is very less because there is no what you call ocean nearby. And Mumbai, it is 35 degrees Celsius and 27.5 degrees Celsius and 70% relative humidity, because Mumbai, we have a seashore there. So indoor design guidelines, and this is the office 24 degree Celsius, humidity can be maintained 50 percentage. Residence 25 degrees Celsius. Hospital ICU, it should be 22 degrees Celsius, and server room, it is still lesser, 21 degrees Celsius, and relative humidity to be maintained between 45 to 55. So the relative humidity in most of the cases, 50 to 55 degree, sorry, percentage. So factors influencing design conditions. So building orientation and envelope design. So building orientation, and whether it is directed, the windows are directed to sun. Maybe windows, if we have windows towards east or west, so there will be during sunrise there will be heat penetration uh, on east side. So when there is windows on west side, there will be heat penetration when the sunset is happening. So that is nothing but orientation. And envelope design, so that is nothing but how many windows we keep, and what is the size of windows we maintain. And type and schedule of occupancy, and geographical location. So for example, how much height from sea level. In Chennai is at low level, and when you compare Kodaikanal or Ooty, it is higher in altitude. And ventilation strategy, natural or mechanical. Thermal insulation and glazing properties. Urban heat island effects in cities. So that is the conditions. Next, we can see the books. These are the books. You can refer CP Arora and RS Kurmi for this particular topic. And this is RS Kurmi is one of the simple book to understand. And this material will be sufficient. I will circulate this material, and this will be sufficient to understand this topic, because it is very simple topic. and we stop here, students. Other resources are online resources, NPTEL, and other. There are many online resources available other than this. You can refer those resources also. So we stop here, students. We will meet in next session, and we have a lengthier session in the next topic. We will discuss that in next session. Thank you, students.